In this video, we're going to talk about how to convert a decimal number into a binary number. So let's go ahead and begin. So how can we convert 75 into a binary number? It helps to be familiar with the powers of 2. 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power is 32, 2 to the sixth power is 64, 2 to the seventh power is 128. Now we don't need to go further because 128 exceeds 75. So the highest number, that is the highest base 2 number that is less than 75 is 64. So we're going to start with 64. Now in this video, I'm going to show you 2 ways to convert a decimal number into a binary number. The first half of the video will focus on the subtraction method, and the second half will focus on successive division. So I'm going to show you both ways, and then you can pick and choose which method you prefer. Now once you have your first number, which is 64 in this case, subtract. Let's subtract 75 by 64, and so that will give us 11. Now the highest number that's under 11 is 8. 16 exceeds 11, so we can't use that. So let's put an 8 here. And then let's subtract 11 by 8. 11 minus 8 is 3. And so the next highest number just under 3 is 2. And so let's put a 2 here. And then 3 minus 2 is 1. And so the next highest number is a 1, and we could stop here. Because if you add these numbers, 64 plus 8, that's 72, 72 plus 2 is 74, 74 plus 1 is 75. These 4 numbers add up to 75. Now once you have that, you can begin to write the numbers in binary. So because we have a 64, we're going to put a 1. We don't have a 32, so let's write a 0. We don't have a 16. We do have an 8, so let's put a 1. We do not have a 4, so let's put a 0. But we do have a 2 and a 1. So 75 is equal to 1001011. And so that's one simple way in which you can convert a decimal number into a binary number. Now here's another example. Let's say if we have the number 142. Let's convert that into a binary number. So let's write the list of numbers that we're going to work with. 128, 64, 32, 16, 8, 4, 2, and 1. So the highest number under 142, the highest base 2 number is 128. So let's start with that. And then if we subtract 142 by 128, that's going to give us 14. And so the next highest number just under 14 is 8. And so 14 minus 8 will give us 6. But let's put the 8 here. Now the next highest number that's under 6 is 4. So if we subtract 6 by 4, that will give us 2. So let's put the 4 here. And then 2 minus 2 will give us 0. So we could stop at the 2. And so you could check it. If you type in 128 plus 8 plus 4 plus 2, that will give you 142. So make sure that these numbers add up to this number. So you want to find all the base 2 numbers that add up to this number. Once you do that, then you can convert it into a binary number. So this is going to be 1. We don't have a 64, nor do we have a 32 or a 16. We do have an 8, a 4, and a 2, and we don't have a 1. So 142 is basically 1, 0, 0, 0, 1, 1, 1, 0. And so that's how you can convert a decimal number into a binary number. Now here's another example. Let's try a bigger number, 339. Go ahead and work on that example. So this time, we need a number that's higher than 128. 128 times 2 is 256. So we're going to start with 256, and then 128, and then 64, 32, 16, 8, 4, 2, and 1. So 256 is the highest number in this list that's just under 339. And so let's subtract 339 by 256. And so this will give us 83. The next highest number, the highest base 2 number that's under 83 is 64. So let's subtract 83 by 64. And that will give us 19. And let's not forget to write the 64 here. Now the next highest number under 19 is 16. So let's do 19 minus 16. And so that will give us 3. And so let's write the 16. And then the next highest number that's under 3 is 2. And so 3 minus 2 is 1. So let's put the 2 here. And then 1 minus 1 is 0. So we need to include the 1 as well. And then check the work. Make sure that these numbers, all of these base 2 numbers, add up to 339. And so type in 256 plus 64 plus 16 plus 2 plus 1. And that will give you 339. Just to make sure that you did everything correctly. Now let's write the numbers. So we have a 256. We do not have a 128. We do have a 64. We do not have a 32. We have a 16. And since we don't have an 8 or a 4, we're going to write a 0. We do have a 2 and a 1, so we'll replace that with a 1. So a 1 means on or yes, and a 0 means off or no. And so this is the answer. So 339 is equal to 10101011. Now the second method involves successive division. And so let's go over the 3 examples that we did using the second method. So this allows us to confirm our answer. So in the first example, we said that 75 is equal to the binary number 10011011. Let's confirm that using successive division. So here's what we need to do. Start with 75 and divide it by 2. 75 divided by 2 is 37.5. So what this means is that it's 37 remainder 1. Now take the 37 and then divide that by 2. So 37 divided by 2 is 18.5. So that's 18 remainder 1. Then take the 18, divide that by 2. 18 divided by 2 is exactly 9, with no remainder, or remainder 0. And then 9 divided by 2 is 4.5. So we say it's 4, remainder 1. And then 4 divided by 2 is exactly 2. So it's 2, remainder 0. And then 2 divided by 2 is 1. Exactly 1, so 1, remainder 0. And then finally, 1 divided by 2, that's basically 0.5. So we could say it's 0, remainder 1. And then we stop here. So at the bottom, you have the MSB, or the most significant bit. At the top, you have the LSB, or the least significant bit. Now, the way you read it is from the most significant bit to the least significant bit. So basically, from the bottom to the top. So look at the numbers that we have. So we have a 1, a 0, and then a 0, 1, 0, 1, 1, which is basically the numbers that we have there. So if you write it from bottom to top, it's 1, 0, 0, 1, 0, 1, 1. So hopefully you see that. And so that's how you can get the same answer using successive division. Now let's go over this second example. So let's say we have 142. Use successive division to convert it to a binary number. So let's divide this by 2. So 142 divided by 2 is exactly 71. So it's 71 with a remainder of 0. And then 71 divided by 2, that's 35.5. So it's 35 remainder 1. And then let's take 35 and divide that by 2. So that's going to be 17.5, or 17 remainder 1. And then 17 divided by 2 is 8.5, so that's 8 remainder 1. And then 8 divided by 2 is exactly 4, so that's 4 remainder 0. And then 4 divided by 2 is exactly 2, so 2 remainder 0. And then 2 divided by 2 is exactly 1, so 1 remainder 0. And then finally, 1 divided by 2 is 0.5, so that's 0 remainder 1. So we're going to read it from the most significant bit to the least significant bit. So from the bottom to the top. So it's going to be 1, 0, 0, 0, 1, 1, 1, 0. Which, if you rewind the video, you'll see that we had this answer. Now let's work on the last example, 339. So let's divide 339 by 2. This will give us 169.5, or 169 remainder 1. And then divide 169 by 2. And so that's going to be 84.5, or 84 remainder 1. And then 84 divided by 2, that's exactly 42. So 42 remainder 0. And then 42 divided by 2 is exactly 21. And then 21 divided by 2, that's 10.5. So it's 10 remainder 1. And 10 divided by 2 is exactly 5. So 5 remainder 0. 5 divided by 2 is 2.5, so that's 2 remainder 1. And then 2 divided by 2 is exactly 1. And 1 divided by 2 is always 0.5, so that's always going to be 0 remainder 1. So let's go from the most to the least significant bit. So starting with the number on the bottom, it's going to be 1, 0, 1, 0, 1, 0, 0, 1, 1. And so this is 339 as a binary number. And so that's it for this video. So now you know how to convert decimal numbers into binary numbers. You have 2 ways of doing it. Thanks for watching.